Today we have with us here in the Mission Control a special guest to talk with us about a new book that's coming out for students or children to learn a little bit more about space nutrition. And that's actually the title of the book, I believe. This is Scott Smith. He is a manager for Nutritional Biochemistry here at Johnson Space Center. And he's going to tell us a little bit about his book that he's been working on. Thanks so much for joining us, Scott.
Sure thing. Thanks, Brandi.
So, okay, now tell us a little bit. It doesn't seem like it's necessarily something you'd expect from NASA to have a children's book. So how did that come about?
Well, this whole effort, as you said, I'm involved with the Nutritional Biochemistry Lab at the Johnson Space Center. I'm a scientist. We do scientific work. We do experiments on the ground. We do experiments on the space station, and that's our full-time job. We're always looking for ways to reach out to help people better understand what we do. And the book that came out recently began with an effort back in 2001. And what we were doing was we were gearing up for a spaceflight experiment on the shuttle. And what we had wanted at the time was we were trying to come up with a way to engage kids in that experience. And there were a number of things we wanted to do. But we sort of had the impression that some folks out there had the idea that the crew showed up the week before a shuttle flight and decided what they were going to do, and that's where those experiments came from.
That's not how it works.
That's usually not how it works. So what we wanted to do is, again, try to highlight our project and bring a group or groups of kids into it to give them an idea of how long that process takes, talk about the scientific method, talk about proposals, talk about experiment, definition and how things get laid out, training, and then literally the breadth of the team that it takes to pull off a spaceflight experiment. And the way we established that, again, back in late 2001, was with a newsletter, a monthly newsletter that we generated for what I usually call upper elementary, intermediate school students.
Okay.
And every month we would highlight a different aspect of the experiment, either the hardware we were preparing, the scientific process, the study itself, human physiology during spaceflight, different things. And we had a great team of folks. One of the co-authors on the book, a woman named Janice Davis Street, was here at the time. And she and I worked on this a lot. And this, again, was one of our, this was a spare time activity. This was not part of our job. We did a lot of this at night, on the weekend. And in the beginning, it was clip art. It looked kind of cheesy. But we had a lot of fun, and it had a lot of impact on the kids. What we've done since then is it's grown a little bit, and NASA at one point actually allowed one of the graphic artists here, a guy named Marco Zambetti, to do illustrations for us. And he developed a cast, if you will, of 4 kids, and would develop imagery to go along with each of the newsletters. So we did that for several years. One of the teachers we worked with was a woman named Lisa Nesbitt. And she was a classroom teacher who was receiving these and would incorporate them into her classroom. And eventually, as fate would have it, a position opened up here at NASA in the education office, and she came to work here and continued her work. But it was almost, from an education point of view, looking over our shoulder at the content to help guide it towards the school and classrooms, and guide it for teachers. And she did some great work with teacher guides and those kinds of things. Somewhere along the way, Dr. Sarah Zwart joined our team, another nutrition scientist, and helped, again, with the content. And the newsletter over the years, I guess back in 2006, 2007, waned a little bit. And what we decided to do, I guess about a year ago, was to repackage and reformulate those newsletters into a book.
Okay.
And we stepped back and essentially started again. And Marco drew new imagery, and we go through everything in the book, from the history of spaceflight. We talk about the different space programs. We talk about the evolution of space food. We talk about things like the scientific method and how you do experiments. We talk about 2 different aspects of what we do in the lab. We talk about things like different nutrients. So we'll have an issue on vitamin D, or an issue on antioxidants, or an issue on calcium, and it's sectioned in the book accordingly to highlight those areas. And then we also talk about the different research that we're doing. So we'll highlight experiments that we're doing literally right now that Kevin Ford is doing on board Space Station, the procedures, the hardware, and everything.
Okay.
And then we also point to the future of where's this going, what are we learning, and what are the implications in the future.
So what is your idea of how this book will be used? Is it for students to read, or for teachers to use in their classroom, or?
Both. I mean, in my head, I look at this as something that again, a fifth, sixth, seventh, eighth grader might want to pick up and read to learn more about what's going on in space. A teacher could use this, and there's actually a teacher's guide in the back of the book, which has tracks to education standards. It has suggestions for how to incorporate this in the classroom, how to adapt the material to different elements. So from an educator point of view, there's clear hooks there that they can use. But again, I, we're looking for people to use it in any way they want.
Sure. So, thinking about teachers, there's so much that kids have to learn. There's so much you have to get done in the classroom today. What would be the value of using something like this? Why is this of interest for kids?
Well, there's two different facets to that. One, I would say that kids are interested in space, and this gives them a good handle on one focused area of spaceflight, an area that there's perhaps not a lot of information out there on. And so I think we engage kids based on the topic. What we can also do, though, is at the same time, you're getting kids to read. There's math activities in there that they can work with. You're teaching them about science. You're teaching them about health. So there's a lot of different spin-off applications. And again, from an educator point of view, there's many things that you can do the same way. The teachers can use this as a way to get kids to write. They can say, here, read this section, and then go off and write what it means to you, or write your version of this, or design a food system that that you could use in your spacecraft. We've seen group projects that teachers have done where they've had kids build different spacecraft, a craft to go back to the moon, or a craft to go off to Mars. So there's a lot of different. There's many ways that you could apply this into the classroom.
Well, I guess if you've been basically doing a version of this since 2001, I think you said,
That's correct.
you must have gotten some indication that people were enjoying it, that it was being used by a lot of teachers. And can you give me an idea of what you've seen?
Absolutely. Again, we've been doing this for a long time, and the feedback we've gotten has been phenomenal. And in our heyday, I think we were sending out, because we posted them on the internet. They're still posted on the internet on NASA's website. But originally we were mailing out hard copies, and I think we were sending out about 900 a month in our heyday. And the response we were getting from teachers, the response we were getting from kids was just outstanding.
Okay. And I think we've got here on the screen, you can see the website where you can go and take a look at the book. It's available in a couple different forms. You can actually purchase it or get it for free via ebook. Is that right?
Well, actually, on the website has several things. That one link will take you to the main page that has our education outreach material on there. All the newsletters I talked about are on there, and then there's links to two forms of the book. There's a PDF file of the book
PDF, okay.
that you can downlink for free. There's also, if you have an iPad, there's an iBook version of it that is on
Available,
iTunes,
yeah.
and that is free as well.
Okay.
So there's a link on our site that will take you to iTunes where you can pull that down if you have an iPad. And again, it's all free.
Okay, so a couple of different ways you might take a look at that and see if it's something that you, or maybe a student you have to get a Christmas gift for, might be interested in. But let me ask you, since we've got you here, what are some of the most interesting experiments that are going on in space? Maybe some that Commander Ford's working on this expedition.
Well, we have two experiments going on these days. Commander Ford is participating in what we call our nutrition experiment, and what he does 5 times over the course of his 6-month mission, he'll collect blood and urine samples for us. Those samples go in the freezer, and then they'll come home on the next Dragon flight, hopefully. And what we're learning from those is many things, but one of the things we're learning is, in essence, how the body adapts to space flight. And one of our recent studies that we published this past year was looking at the effect of exercise on bone. And what we were able to show is that the new what we call the resistance exercise device, the weightlifting machine, actually helps to protect bone in spaceflight.
And that's as opposed to the exercise bike and the treadmill, that sort of
That's
thing?
correct. The bike and the treadmill are what we call aerobic devices.
Mm-hmm.
The resistance exercise device is essentially a way for astronauts to lift weights during flight. And while the bike and the treadmill are great for muscles and your heart, what we've known for some time now is that the bones, to maintain bone health during spaceflight, you really need to lift weights, which in a weightless environment becomes very tough. But what we've shown again recently is that the resistance exercise device we have on station right now works the crew members hard enough that they can maintain their bone. So that was sort of an exciting thing that we just published recently.
Absolutely. So is that included in the book, or does it go that far in
Unfortunately, the book ended just before that. We
just
were
before
talking about
that?
that recently. That we need there's a couple things we need to update in the book. But I guess that'll be the second edition.
That sounds good. Let me ask you though, how do you take something like that and turn it into something of interest to children?
Well, everything that we study, when we talk about bone in particular, um, one of the obvious ties with bone health in the astronauts and on Earth is osteoporosis. And osteoporosis obviously is a disease that affects elderly individuals. Um, but when you talk about preventing osteoporosis, the point of prevention of osteoporosis is in kids. That what we need is kids to eat better when they're younger because by the time you reach about 20, 25 years of age, your skeleton is done. That you have nothing left to do but lose it. So what the trick is to try to get as much skeleton as you can. And the way to do that is to eat better when you're a kid, when you're 12 to 15 to 18. Um, Eating well, getting lots of calcium, getting lots of protein, getting lots of vitamin D is critical to establish health. So what we try to do is we talk not only about the crews exercising in flight and what that means for them, but how that affects the kids as well.
Okay, so it might also be a good tool for moms trying to get their children to eat right. They can tell them that you need to do that to be an astronaut.
Absolutely.